In this question, we have to find the fourth term from the n in the expansion of the given binomial expression. So, n here is equals to 7, which implies that the number of terms is equals to n plus 1. Meaning, so there are 8 terms. Now to find out the fourth term from the n, what we do, we can instead find out the term from the beginning. So we can rewrite the fourth term from the n is equals to the number of terms, which is 8. Then we subtract the 4 terms from the end. And since we have subtracted 4 terms, we have to add 1 to it. So that gives us, which 8 plus 1 is 9, 9 minus 4 is 5. So this is equal to saying the fifth term from the beginning. So we calculate T5. So T5 is equals to T 4 plus 1, which is equals to 7C4. We have the first term, which is 3 over x squared, all raised to the power of 7 minus 4, so that is 3, times the second term, which is negative x cubed over 6 raised to the power of 4. Now we simplify the values. So 7c4, we have 3 raised to the power of 3 divided by x raised to the power of 2 times 3, which is 6, times negative 1 raised to the power of 4. So we have just pulled out the negative from the inside of the second term, times x raised to the power of 3 times 4 is 12, divided by 6 raised to the power of 4. So we take all the constants and write it together. So we have 7c4 times 3 raised to the power of 3 divided by 6 raised to the power of 4. Now negative 1 raised to the power of 4 is positive 1. And then we have x raised to the power of 12 minus 6. So we use a calculator to find out the value. So 7c4 is 35 times 3 raised to the power 3 is 27 divided by 6 raised to the power of 4 is 1296 times x raised to the power of 6. And the final calculation will give us 35 over 48 x raised to the power of 6. So this is the fourth term from the end in the given binomial expression. There we go. Let's go to the next one. So this is similar to the previous one. Here we have to find the 11th term from the end in the expansion of this. So we have the number of terms. The number of terms is going to be equals to 25 plus 1. So this is 26. So this is the number of terms, which will 26 terms. Now to find out the 11th term, the 11th term from the end is equals to, we take the total number of terms, we subtract 11 from it, and then add 1 to it to give us the number of terms from the beginning. So this will be equals to 15th. So this is the 15th term, which is equal 15th term from the beginning, which will be equal to the 11th term from the end. This is in the beginning. Now we find out the value of T15. So T15 is equals to T14 plus 1, which is equals to 25C14. We take the first term, which is twice x, and 25 minus 14. 25 minus 14. Fuck, man. So in this question, we have to find out the 11th term from the end in the expansion of twice x minus 1 over x squared raised to the power of 25. So first we count the number of terms. So the number of terms will be equal to 25 plus 1. So we have 26 terms here. Now to find out the 11th term, so we write the 11th term from the end is equals to, we take the total number of terms, then we subtract 11 terms, and then we add 1 to it. So we have 26 minus 11 is 15, and 15 plus 1 is 16. So 16th term from the beginning. So there we go. So we now find out the value of T16. So T16 is going to be equals to T15 plus 1, which is equals to 25C15. The first term will be twice x raised to the power of 25 minus 15, which is 10, times negative 1 over x squared raised to the power of 15. Now we simplify the values. So 25C15, we have 2 raised to the power of 10 times x raised to the power of 10. We pull out the negative 1. So we have negative 1 raised to the power of 15 times 1 over x squared raised to the power of 15, which will be simply 2 times 15. That gives us x raised to the power of 30. Then we take the negative 1 raised to the power of 15 will give us a negative. So we take it in the front. Then we have 25C15 times 2 raised to the power of 10 times 1 over x to the power 30. Now what we have x raised to the power of 10 in the numerator. So when we bring it down to the denominator, the index gets subtracted. So we'll have 30 minus 10 in the denominator. So the final answer will be 20 minus of 25C15. 2 raised to the power 10 is 1024 divided by x raised to the power of 20. Therefore, you can go ahead and use a calculator and find the value of 25C15 and multiply that to 1024, but I'm leaving it the way it is. Let's go to the next one. So in this question, we're given a binomial expression and we are to find the value of n. The condition given here is the ratio of the fifth term from the beginning to that of the fifth term from the end is root 6 is to 1. So let's begin. So let's find out the fifth term from the end. So we have the number of terms. So the number of terms is equals to n plus 1. So we have the number of terms here. Now what we do? We find out the fifth term from the end. The fifth term from the end is simply going to be, we consider the total number of terms, then we subtract 5 from it, and then we add 1 to it. So this is going to be equals to n minus 3. So this is the n minus 3th term from the beginning. From the beginning. So there we go. So we now find out the fifth term from the beginning. So that is t5, which will be equals to t4 plus 1 equals to nc4. So the first term is the fourth root of 2, which could be written as 2 raised to the power of 1 over 4 whole raised to the power of n minus 4 times 1 over 3 raised to the power of 1 by 4, the whole thing raised to the power of 4. We simplify it, so this will give us nc4. So we have 2 raised to the power of n minus 4 divided by 4, whole thing divided by 3 raised to the power of 1/4 times 4 will be simply 3. So let's call it equation number 1. Then we find out the value of the n minus 3rd term. So this will be t n minus 3. This will be equal to t n minus of 4 plus 1. We can rewrite n minus 3 as n minus 4 plus 1, which will be equals to nc n minus 4. The first term will be 2 1 raised to the power of 4, 2 raised to the power of 1/4 whole raised to the power of n minus 4. That will give us simply 4 times 1 over 3 raised to the power of 1/4. The whole thing will be raised to the power of n minus 4. So that would give us simply nc n minus 4. So 2 1/4 raised to the power of 1/4 times 4 will simply give us 2. And the denominator will have 3 raised to the power of n minus 4 divided by 4. So let this be equation number 2. So, well, to find out it's also to find out n, we use the condition that the ratio of 1 to 2 is root 6 is to 1. So we divide 1 by 2. And that gives us t, and it's given that in the equation, in the question it's given that t5 over t raised to the power n minus 3 is equals to root 6 over 1. So we replace the value of t5, which is nc4 times 2 raised to the power of n minus 4 over, we will write it as n minus 4 over 4 divided by 3, and the whole thing is divided by nc n minus 4. We have 2 over 3 raised to the power of n minus 4. We'll write the 4 here, n minus 4 over 4, and this is equals to root 6. Now we know that nc4, this is a property of combinations, that nc4 is always equals to nc n minus 4 if n is equals to 4 plus n minus 4. That is to say, let me generalize this. That means if we have NCR, then this must be equals to NC R n minus R. So this is the property. So this cancels out the first coefficient, which is NC4, and NCN minus 4. Now we simplify this expression. So we'll be left with 2 raised to the power of n minus 4 over 4 divided by 3 times 3 raised to the power of n minus 4 over 4 divided by 2, which is equals to root 6. Then we combine the 2 in the numerator and denominator, so we'll have 2 raised to the power of n minus 4 over 4 minus 1. We simply subtract the exponents, times 3 raised to the power of n minus 4 divided by 4 minus of 1, which is equals to square root of 6. So further going ahead, we'll have 2 raised to the power of n minus 8 over 4 times 3 raised to the power of n minus 8 over 4, which will be equals to 6 raised to the power of half. This is square root of 6. Now we can combine the base since the exponents are equal, so we'll have simply 2 times 3 raised to the power of n minus 8 over 4, which is equals to 6 raised to the power of half. 2 times 3 is 6. 6 raised to the power n minus 8 over 4, which is equals to 6 raised to the power of half. Now the law of exponents states that the exponents must be equal, so we'll have n minus 4, n minus 8 over 4 must be equals to half. Then we solve for n. That should give us n minus 8 equals to 4 over 2, which is going to be simply 2, so that gives us n is equals to 10. So there you go. So that's the value of 10. Let's go to the next. So here we have to find out the seventh term from the end in the expansion of the given binomial expression. So let's find out the number of terms first. So we have the number of terms. The number of terms is equals to, so 8 plus 1, which is equals to n. Now the first seventh term, with the seventh term from the end is equals to, we take the number of terms, then we subtract 7 from it, and then we add 1 to it. So 9 minus 7 is 2, 2 plus 1 is 3. So this will be equals to the third term from the beginning. So now we find out the value of t3, which is simply t2 plus 1, which is equals to 8c2. The first term is 2x squared whole raised to the power of 8 minus 2, which is 6 times negative 3 over 2x raised to the power of 2. Now we find out the value of 8c2. So let me use my calculator. 8c2 is 28. So we're 28 times 2 raised to the power of 6 times x raised to the power of 2 times 6 is 12. Let's go. But then we pull out the negative number, which is negative 1 raised to the power of 2. And we have 3 of squared, and the whole thing is divided by 2 squared times x squared. So we do let's use the calculator for this. So we have 28 times 2 raised to the power of 6 times 3 squared, which is 9, all thing divided by 4, so we get 4032. We get 4032. Negative 1 raised to the power of 2 is simply going to be 1. Then we have x raised to the power of 12, and we subtract the 2, which is the exponent of x in the denominator, by taking it to the numerator. So the final answer will be 4032 x raised to the power of 10. So this is the seventh term from the end in the expansion. Let's go to the next one. So we have to find out the fourth term from the end in the expansion. So the number of terms. So we have the number of terms equals to 9 plus 1, which is equals to 10. Then we find out the fourth term from the n, and that is equals to 10 minus 4, and we add 1 to it. So 10 minus 4 is 6, 6 plus 1 is 7. So the fourth term from the n is equals to the seventh term from the beginning. So now we find out the value of t7, which is equals to t6 plus 1, and then we use the expansion 9c6. The first term is 4x over 5, 4x over 5 raised to the power of 9 minus 6, which is 3, times negative 5 over 2x raised to the power of 6, which is equals to 9c6. The 4 can be rewritten as 2 squared, so 2 squared raised to the power of 3 will be 6. 2 raised to the power of 6 times x cubed divided by 5 raised to the power of 3 times, we take out the negative, which is negative 1 raised to the power of 6 times 5 raised to the power of 6, all divided by 2 raised to the power of 6 times x raised to the power of 6. So clearly we see here that 2 raised to the power 6 will factor out the 2 raised to the power 6 in the denominator, and that should give us 9c6. Negative 1 raised to the power 6 is positive, then 5 raised to the power of 6 minus 3 times x raised to the power of 3 minus 6, which is equals to 9c6, 5 raised to the power of 3 times x raised to the power of negative 3. So we find out the value using a calculator. So 9c6 is going to be 84 times 5 raised to the power 3 is 125. So we have 10,500 times x raised to the power of negative 3. So this is the fourth term from the end. So here we have to find out the fifth term from the end and the expansion of thrice x minus 1 over x squared raised to the power of 10. So number of terms, in a similar fashion, number of terms is equals to 10 plus 1, which is equals to 11. Since we have to find out the fifth term, so we can say fifth term from end is equals to total number of terms minus the fifth term plus 1. So this will be equals to the 11 minus 5 is 6, 6 plus 1 is 7. So this will be equals to the seventh term. From the beginning. So we find out T7, which is equals to 10C6. The first term is thrice x raised to the power of 10 minus 6 is 4 times negative 1 over x squared raised to the power of 6. Now we simplify the values. We have 10C6, 3 raised to the power of 4 times x raised to the power of 4, negative 1 raised to the power of 6 divided by x squared raised to the power of 2 times 6 is 12. So So this is equals to 10c6. 3 raised to the power 4 is 81. Negative 1 raised to the power of 6 is positive 1. And then we take x raised to the power 4 to the denominator and subtract the exponent from the exponent of the denominator. It will be 12 minus 4. Then we find the value of 10c6 using a calculator, which gives us 210 times 81 divided by x raised to the power of 12 minus 4 is 8, which is equals to 17,010 divided by x raised to the power of 8. So that is the answer. So in this question, we are given a binomial expression, x plus 2 over x raised to the power of 9, and we have to determine the fourth term from the beginning and the fourth term from the end. So let's begin by first finding out the fourth term from the beginning. Yes, we have to find out t4. So t4 would be simply t3 plus 1, which is equals to 9c3 x raised to the power of 9 minus 3, which is 6 times 2 over x raised to the power of 3. Which is equals to 9c3 times x raised to the power of 6 times 2 raised to the power of 3 divided by x cubed. So we find out the value of 9c3, and that's 84. So this gives us 84 times 2 raised to the power of 3. So that's simply 8. And x raised to the power, so we subtract the exponent and the exponent of x in the numerator. No, we subtract the exponent of x in the denominator from the exponent of x in the numerator. So that will be simply x raised to the power of 6 minus 3. So 84 times 8 gives us 672 times x raised to the power of 3. So this is the fourth term from the beginning. Now to find out the fourth term from the end, we need to find out the number of terms. The total number of terms will be equals to n plus 1. So we have n equals to 9 here. So we have a 9 plus 1, which is equals to 10. So there are total 10 terms. Now, the fourth term from the end, is going to be equal to 10 minus 4 plus 1. So 10 minus 4 is 6, and 6 plus 1 gives us 7. So we have to find out the seventh term from the beginning. It's the same thing. So then we have to find now t7. Now t7 is going to be equals to, and ours is 9c6. So the first term is x. So this will be simply x cubed times 2 over 6, 2 over x raised to the power of 6, which is equals to 9c6. Now 9c6 is equals to 9c3, which follows from the property of combination. So that will be 84 times x cubed, and we have 2 raised to the power of 6, and that is 64, divided by x raised to the power of 6, which is equals to 84 times 64 is 5,376. And then we subtract the exponent of x in the denominator and the exponent of x in the numerator. So that would give us x cubed in the denominator. So 5376 divided by x cubed, and this is the fourth term from the end. So there we go.